Probability and statistics. My name is Jitendra. My topic is about maximal correlation and regression. Abstract. In this paper, we propose a novel regression analysis approach called maximal correlation regression by exploiting the ideas from Hirschfeld, Gibelin, Renyi, HGR. Maximal correlation. We show that in supervised learning problem, the optimal weights in maximal correlation regression can be expressed analytically with the relationships to the HGR maximal correlation functions, which reveal the theoretical insight for approach. In addition, we apply the maximal correlation regression to deep learning, in which efficient training algorithms are proposed for learning the weight in hidden layers. Furthermore, we illustrate the maximal correlation regression in deeply connected to several existing approaches in information theory and machine learning, including the universal features selection problem, linear discriminant analysis, and the softmax regression. Finally, experiment on real data set demonstrate that our approach can be obtained performance comparable to the widely used softmax base regression based method. Maximal correlation regression. Let the variable x and y with range x and y be the data label, and the xi yi for I is equal to 1 so on n be the data samples in training set. We denote pxy comma px and py as the joint distribution, marginal distribution of x and y respectively. Since the label y is typically discrete with y mod n in the sequel, we assume that the py is known from training set and take y is equal to 1 comma y mod without loss generality. The regression approach. The main idea of maximal correlation regression is to approximate the conditional distribution py by x by a function p of f comma g comma b y by x defined as given k dimensional functions f of dot and g of dot of x and y, and a scalar functions b of dot of y. We define the functions p to the power of f comma g comma b y by x as this equation. P to the power of f comma g comma b y by x is equal to py of small y into 1 plus ft of x g of y plus b of y. To measure the difference between py by x and p of g p of f comma g comma b y by x, whose operational meaning will become clear later. When connecting to HGR maximal correlation and softmax regression, note that L of f comma g comma b greater than less than 0, where the inequality holds with quality if and only one if p of f comma g comma b y by x is equal to p by x small y by x for all x comma y. Then the maximal correlation regression is introduced as definition to maximal correlation regression. Given the input features of f of x proportional to rk, the maximal correlation regression MCR model py by x with the parameterized function p of x comma g comma b y by x regression, where g is equal to y7 tens of rk and b y7 tens r are designed to minimize L of f comma g comma b. Unlike softmax regression, the optional parameters g and b in MCR have analytical expressions which are established as follow. For a given feature x, we have all y is proportional to capital Y. This is the function g of y is equal to a to the power of minus 1 f of x y is equal to y b of y is equal to minus mu t of g of y. Then for a new data sample, we can predict the corresponding label by the maximum posterior decision rule y of x gi. This is the function with complete the label prediction by MCR with a deep meaning. This section the features is given in the regression in general. This f can be generated Some model f of theta parameterized by theta. Example, deep learning deep network with theta as the weight and basis of the hidden layers, and the loss L of f theta comma g comma b shall be optimized jointly over g comma b and theta. In such cases we shall train the optimal G comma B and theta from training sample by scochatic gradient descent. Note note that the quantity L of f theta comma g comma b cannot directly estimated from the training samples, since py by x into small y by x is generally known. The following result shows that we can equivalently optimize another quantity called h score. Uh, and denote the optional parameters that minimize L of f theta comma g comma b. Then we have theta is equal to theta h, and for all y is proportional to capital Y, and this is the equation for the theta comma g comma b. Not a neutral network architecture designed for the jointly training process is provided appendix. So after obtaining theta h and gh from training using the propagation 2, we can retrieve the corresponding optimal parameters theta comma g comma b from the data samples. The competition details are summarized algorithm 2. Then for a new observation x, the corresponding label can be predicted by the map decisions rules y by x given by this equation. Y by y of x arg max p to the power of f theta comma g comma b y dash by x. This is a table for algorithm to parameters travel for mcr. Some inputs are given for this, and it will be defining the output. Theoretical properties. We now demonstrate that the optimizing parameters of MCR is equivalent to solving a row rank approximation problem of some normalized joint probability matrix. For simplicity of exposition, we assume x is also discrete with a range x is equal to y comma x mod. In addition, the following equivalent representation of f and g will be useful in our analysis. This is a equations which is used to the following result characterizes low rank approximation of MCR, and the equation for conical dependence matrices whose x comma y the entry, and where the matrix ey and ex are defined 9, that mu t g af mu g plus summation y proportional to this p of y mu t g g of y plus by whole square is greater than equal to 0, where the inequality holds with equality if and only if mu g is equal to 0 and by is equal to minus mu 2g of y small y is proportional to capital Y, where hyf is a single sided h score 1 of f of x as defined. This is the equation totally defined for this derivation. G af to the power of minus 1 e into f of x by y is equal to y tends to g of y. Ag to the power of minus 1 e into g minus y by x is equal to x tends to f of x. The proportional one can be interpreted one step of ACE algorithm. Moreover, when both G and are said to be optimal result the L of f comma g comma b is equal to mod b square f minus 2hy of x. The single headed. In this this is the equation for the theorem 1. MCR and let ACC denote accuracy of max prediction. ACC is greater than or equal to 1 plus beta 1 plus b mod square f greater than and equal to 1 plus 2hy of f, and the acc minus acc f whole square less than equal to 2, mod b square f minus 2hy of f less than or equal to mod 2 into mod minus mod y minus 1 minus 2hy of f p max. Relationship to the hgr maximum concentration. The hgr maximum concentration is defined to this function. mm, Function connection to the existing approaches a universal feature selection. Now I'll illustrate the features f extracted by mcr can be interpreted as selecting the optimal features x that minimize the error or interfere attributes of y, which can be formalized as universal selection problem. Through this universal selection features of selection, the formula was derived. Theta is equal to theta h plus arg max into max h of f theta g is equal to arg max hy f of theta. F of theta. Therefore the optimal theta of mcr minimize the side headed over the parameters theta of deep neural network, which equivalent minimize the error probability in universal feature selection. As a result, the feature of extracted of mcr approach is also the optimal universal features among the parameterized function f of theta minimize the average inference error. Linear discriminant. From the perspective of the feature space, the feature extracted by the mcr approach, which means that the feature for a different label are separated. Hy of f is equal to tr into s to the power of minus 1 t, sb is equal to tr a of af to the power of minus cov into e into f of x by why. This way, this is the function for linear discriminant analysis, where delta f is referred to total scatter matrix, and the delta l is a total scatter matrix. The operational meaning of hy of f is measuring the class separability can be characterized as follow. Hy of f is just formula e into mod e f of x by y whole square. Therefore the softmax regression. In softmax regression, given a k dimensional features of x, the conditional probability p y by x is modeled by soft matrix function in the form. In this form, p to the power of f comma g comma b y by x is equal to e to the power of f of t into x f of g plus b of y divided by summation y proportional to y e f of t x into g of y dash plus b of y dash, where G and B represent the weights and bases in addition. When f can be also designed by the some parameterized function computing the optional choice f comma g comma b is the equivalent training neural network using a labeled sampled xi comma yi. Ni is equal to 1 of x comma y. The optimal parameters f comma g comma b that minimize the log likelihood functions are given. F comma g comma b is equal to arg max minus summation I is equal to 1 n log p by x yi by xi. This is a diagram for a neutral network classification, where inputs are given for a hidden layer, and the outputs will be driven by the softmax neutral. Therefore our analysis in mcr can be provided useful sites in understanding much more complex features extracting schemes in deep experiment. In this experiment, in a mcr performance in practice, we design experiment experiment on a mixed data set CIFAR CI 100. They are driven some expressions and functions in mixed database. Handwritten is one of the most common tied to y data set in computer vision, which train a set of 60,000 examples and test a set of 10,000 examples to extract the features from mixed. We adapt a simple two layer convolution neural network as a duplicate as a despite in a particular. We set the features of dimension to k is equal to 10. Then both the MCR and classic SL model are trained for 100 epochs using adult data, where the learning rate is said to be zero point 0.1 with a decay factor of 0.95 and mini batch set to 32 with the entire 60,000. In this graph represented by the visualizations of features f theta generated by MCR classes SL network on the test set of mixed used for training. The right side graph is represented by the training and test as series of MCR method on CIFR compared with the result for method SL method. CIFAR furtherly conducted an experiment for CIFAR 10 data, which consists of 50,000 training images and 10,000 testing images in 10 classes. In particular, we use reset 18 to generate the features f theta with the dimension k 512 and follow the training setting in which have been tuned on the classic SL model. We used SDG with a weight decay 10 into 5, 5 into 10 minus 4 and a moment of 0.9, and train both the MCP model SL model up to 35 lobes. During the training process, the learning rate starts from 0.1 and is divided by 10 at epochs of 150 and 250. The topmost right side diagram represents the training and test accuracies of MCR on CIFAR 100 compared with result for the classic SL. Thank you.